Welcome children, this is Ajay and welcome in Career Foundation. Today's class is class 10th, real number. No, some video I have just put in this YouTube, you might have seen. Now today's topic is revising irrational number. And in this topic, irrational number, we will prove the irrationality of the number like root 2. No, root 2 is irrational, root 3, root p, like this. Irrationality of the number. Okay? Now, without wasting any time, let us start. Okay? To prove the irrationality of the number, first of all, we will need one theorem. Okay? And that theorem is theorem 1.3. Let p be a prime number. Suppose if any number p is a prime number if p divides a square. Suppose this a square is divided by p and remainder is 0 divided by p. Completely divided. The remainder r is 0. Then this theorem says that this A will also be divided by P and remainder will be 0, means completely divided by this. If P completely divide A square, P will completely divide A also. This theorem we have to prove. And with the base of this theorem, on the basis of this theorem, we will prove the irrationality of the irrational number like root 2, root 3, root 5, no? Under root, all the prime number under root, like this number. Okay, let us start. Okay, okay. Let us see. Let the prime. Suppose let the prime factorization of A in this, let the prime factor, means let the prime factor of A B as how prime factor of A. You know what is the prime factor? No? You know, suppose it is 12, the prime factor 2, 6, 3, like this, 2, 2, 3. That you basic you know, okay? The prime factor of A, A equal to, suppose prime factor of A equal to something, let it is P1 into P2 into P3, like this, Pn. Okay, prime factor of A. Then what theorem says? A square. Okay, and there let P be a prime number. Okay, so then A square will be what? Then A square will be same this square. No? Suppose this is factor A square means 2 times A. So that means P1 into P2 into P3 P1 and this is square. Okay? Means square of this whole number. A square means this set also is square. That okay? Okay. So I should I should speak in Hindi also. Sorry. Okay. क्या है इधर? Let P be a prime number if P is dividing A square means यदि P A square को divide करता है then P will also divide A. P will also divide A. So in that let the prime factor of A, this A be like this, then A square will be same. Some factor into of the prime factor and square because this is the prime factor of A, then square means same. Okay, up to here clear? Okay. Then suppose if P and P divides this, okay, P divides this, Suppose A square is divided by P. If A square is divided by P, that means what? P is factor of A. No. P is factor of A square. Okay. P is factor of A. And all the factor of A is written here. P is factor of A square. This A square. If P is factor of A square, one factor of A square, and all the factor of A square is written here, that means certainly this P belongs to among these. No? This is clear? So we will, so then we have to write as per the theorem, if P is factor of A square, so then here all the factor of A square. P is factor of A square, then P have to be among this group. That means P1 into P2 into P3 Pn square. Okay. Any number. Okay. Already we understood that any number, if in the square form, the prime factor has to be on the base. No, suppose any number you take. 64, no, any other number 72. Do this factor. क्या हो गया? तीन दूनी 36, 18 दूनी 36, 2 9 दूनी 18, 3 3 9. See how the number is like this. 2 3 times. That means 2 3 times. 3 2 times. Sorry. 3 2 times. See how many number of prime factor may be more, but the base has to be a prime number. Okay. The same way, if any factor, no, any prime number is among these factors, it has to be in the base. No, the same way, if P, understand here, if P is factor of A square, suppose this P is factor of this A square, all the factor are written here. That means P has to be in the base, and this is the power of the base. Okay, understood? So if P is factor of A square, then P have to be among this set A square or in the base, or P is among, yeah, this set P1 into P2 dot 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 Pn under this base set. P has to be in this set. Okay. So if P is in this set, among this set, and this set is factor of A. No, this set is factor of A among P square. P is among this set. Okay. This P1, P2 dot dot Pn is factors of A. इसका factor, this A. So this means what? P is factor of A means P divides A, or P divides A. So that means if P is a prime factor of A square, no, that means P here, P was part of A square, then P is part of A also. Proved? Okay? Proved. Understood? What we have done? Again dividing in just two lines. Let the prime factor of A be like this. No, prime factor of a p1 p2 pn. Then if do a square left side a square, right side the whole set square. Like this will be there. And as per the theorem, p is prime number and p divides a square. As per theorem, p divides a square. Divide means kya? If any number divides a square, that means that number is factor of a square. Okay, if p is factor of a square, then p have to be among this. Why? These are all the number, all the factors of a square. So p has to be among this. Okay, if p is among this, p is factor of a square. And this same base without square, same base is factor of a, then p has to be among this. That means among these factors, p has to be. If p is factor of among this, so p is factor of a, that means that number which was dividing a square, this is dividing a also. This is one. Okay. Okay, this is proved. Now, next is on the this basis, this theorem we will prove irrationality of root 2, that is theorem 1.4. Now let us go to theorem 1.4. Okay. 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 What is theorem 1.4? Root 2 is irrational. Okay, prove that root 2 is irrational. We will prove that root 2 is irrational. This we have to prove. Okay, we will take help of that theorem. For this, what we have to do? Suppose let assume the just opposite. It is irrational. Let 2 be a rational number. Rational number. Let root 2 be a rational number. If any number is rational, that means this number is some denominator by numerator has to be number. Then what will be the form of number? Root 2, suppose here. Okay. Form of the number root 2 is equal to p by q. Okay. And if these are not co-prime, then if it is cut like A by B, where A and B are co-prime. Co-prime number, I think you are aware of this co-prime. Co-prime means any number like 9 by 16. Okay, this is co-prime number. No common factor. Okay, that you know. So co-prime. If this 9 by 16, there is no common factor, then only co-prime. If, if I prove, no, if we prove that any number which is factor of this also and this also, then these two number will not be co-prime. So then this let means assumption will be wrong. No, so we will prove like this. Okay, this A and B here are co-prime, but we will prove one number which will be factor of this also, factor of this also. Then this A by B will not be a co-prime, and this let assumption will be wrong. Then adverse assumption will considered be correct. Okay. Now let us start. What is this? Root 2a by b. Now, okay, further develop this equation. Root 2 is equal to a by b if both sides do square. So this root 2 square, left side, the right side also square. This will be a by b square. Then root 2 square means 2. No, here a square, b square. So this is equal to a square by b square. Okay. Now if you bring this b square this side, this will be 2b square equal to a square. Okay. What is this here? This a square has a factor of b. b 2 into b square. This 2 is factor of a square. No. Here 2 is factor means 2 is factor of a square. So with that theorem 1.3, 2 is factor of a also. No, a. No. Here if suppose if 2 is factor of a square, 2 is factor of a also. No, theorem. Right theorem. Okay, with the theorem. Factor of a square. We have proved, no, we have got this a, no, this a by b is co-prime. We have got 2 as a factor of a square. Okay, 2 is factor of a square, right? Make one equation. 2 is factor of a square. Here, give name of this equation. Theorem. Suppose a, this is equation a. Now we have to prove. If we prove this 2 is factor of b also, we have proved 2 is factor of a square. No, this 2 is factor of, sorry, a. We have proved 2 is factor of a. If we are able to prove p is factor of b also, then these two number will not be co-prime. We will do that. Okay. Here, see if 2 is factor of a square, that means if 2 factor, no need to write again and again. By this equation a means 2 is factor of a square, we can write 2 equal to 2 into c. This is factor c, any other number 2 into c, or 2c you can write, like directly 2c. 2 is equal to 2c. No, here c is any other number, but 2 is factor of, sorry, 2 a is equal to 2c. 2 is factor of a. So that means a is equal to 2c. Here 2 is factor and this is another number c. A is equal to 2c. Give name an equation 1. A is equal to 2c. This a is equal to 2c. No, let. Should write let, because c we have assumed any new number. No? Let, right, let. And give equation 1. Here a equal to 2c. This value of this 2c we will put in place of a in this equation. This equation we can put here. No, a square. So here, yeah, here also we can put a square. So 2b square, or 2b here also we can put. Let's put b here. Okay. Give name of equation. This is a. Suppose if you give this is a and give this is 2, no, then it will be better. Hmm? So now value of this 2, no, a is equal to 2c in equation 1. Okay. Then what will be there? Value of this 2 in equation 1 put. Otherwise write from equation 1 and 2. Now considering this both equation, this and this. Considering this both equation, this and this, we can write like this 2b square. No, this 2b square is equal to, in place of a, we will write here 2c and square. Okay, then solve this. This is left side 2b square, right side 4c square. 4c square. So only b square is equal to what? Here b square is equal to this 4c square. This 2 if you put down, this is 2. 2c square. That means b square is equal to, can write b square is equal to 2c square. Here 2 is factor of b square. No, what is here? 2 is factor of b square. इसलिए 2 is factor of b also. B also theorem, no? By theorem. So 2 is factor of b also. This 2 is factor of b also. We can give name equation b. No, here 2 is factor of a, here 2 is factor of b. With this a and b, no, with this two equation, no, equation a with equation a and b, 2 is factor of a, 2 is factor of b, can say a and b are not co-prime. Why? Common factor is 4, not co-prime, as 2 is common factor. 2 is common factor. That means what? This late to be a rational number assumption. Okay. This late assumption a rational number is wrong. No. Co-prime. Here we have assumed this is a, sorry, as 2 is common factor, not co-prime. Here we assume it is a co-prime. So this is adverse. इसलिए this is adverse. इसलिए this is root 2 equal to rational is wrong assumption है ना. It is wrong assumption. No, it was not correct assumption because A and B should be co-prime, but we have proved it is not co-prime. Wrong assumption. So then correct is what? Correct is root 2 equal to irrational. Is irrational, and that is proved. Okay, irrational, and that is true. Okay, again in one thought, I will revise you. Okay, what we have done? I have done. We have to prove that root 2 is irrational. For that, let just opposite root 2 a rational number. If any number is rational, p by q form we can write. And if this two number is not co-prime, we will cut with a prime number. We will cut with a number in lowest form. And in lowest form, these two will be co-prime, no common factor. So A by B co-prime. Okay. Now we have to prove this any one factor, 2 will be the factor of A also, B also. That we will prove. If like this, any one number which is factor of both, then it will not be co-prime. For that, solve this equation. Root 2, B bring this side, root 2 equal to A by B. A by B, both sides square. No, root 2 square A square, B square, like this, develop this A root 2 square to 2, A square, B square up to here. Bring B square here, 2B square equal to A square. This is equation 1. Okay. Here A square have a factor of 2 and B square. That means 2 is a factor of A square. This is equation. Okay. If 2 is factor of A square, then 2 has to be a factor of A also with the theorem. This 2 is factor of A also by theorem given name of equation A. Okay. Now again, if 2 is factor of A, that means 2 into something is equal to A. That something if we let C, 2 is equal to 2C, let equation 2. And this 2C put in value of this A in square. What will be there? 2B here, 2B square is equal to here in place of A, 2C square. This will be 2B square, here 2 to the 4, C square. So 2B square here and 2 to the 4 and C square. And this only B square. 2 will go down, 4C here and cut to the, that means 2B square is equal to 2C square. No, B square is equal to 2C square. Here clearly the B square has a 2 factor 2 and C square. That means 2 is factor of B square. And by that theorem, 2 has to be a factor of B also. Here 2 is factor of B square. So 2 is factor of B also. Another equation. Earlier it was 2 is factor of A, here 2 is factor of B. That means A and B both are not co-prime number. And whereas we have assumed root 2 is a co-prime number. Okay? This assumption is wrong, not correct. So that means that late assumption, this late root 2 be irrational is also not correct. That means correct is irrational. So prove root 2 is irrational. Okay? See, this is the way, with this way, we can prove any prime number under root. No. Any prime number under root are irrational. This way we can prove. Okay. So let us, if in place of, suppose, in place of root 2, if you want to prove that root 3, very simple, same way we can do. No, let us do. Suppose prove that root 3. No, here in this board I can delete and write. No, you will understand. No, take a screenshot or you can write also. Okay, whatever is easy, do. So here, in place of root 2, if suppose root 5 is there, root 3, root 5, any, suppose I write root 5. Root 5 is irrational. Root 3, any number you can write. Okay, so here I have written root 5. First of all, let write root 3. No, you will be interested in root. Root 3 is irrational. What again? Let root in place of root 2 write root 3. Root is a rational number. Root 3 be a rational number. So root 3 is equal to P by Q, A by B, A and B co-prime same. No, root 3 same. So again, root 3, this left side, in place of root 2, everywhere we have to write root 3. Root 3 is equal to A by B. Here, root 3 square, left side is square, right side is square. A by B whole square. Root 3 square is equal to root 3. Sorry, 3. Root gone, root 3 square, only 3. A square, B square. That means 3 is factor of here B this side, so 3 into B square. 3 is factor of here A square. 3 into B square. 3 and B square, 2 factor of A square. So that means 3 is dividing the number of A square, 3 will divide A also. Here 3 is factor of A square, then 3 is factor of A also. This is equation 1. And again, 3 is factor of A, that means A is equal to 3 into any other number. Let that number be C. And this 3C, who put value here in place of A, 3C, so this equation will be 3B square is equal to, here 3B square is equal to 3C square. So here 3B square is equal to, here 3 3 the 9C square. And again go forward. Here only B square, this 9C square by 3. So here 9C square by 3. It will cut 3 ja. No, so B square is equal to 3 into C square. So here B square is equal to 3 into C square. Here that means B square has a two factors, 3 and C square. So that means B is factor of 3 is factor of B square. No, these two factors, so this is factor of B square. This has to be factor of B also. So here 3 is factor of B square. So 3 is factor of B also, equation B. So like this earlier, 3 is factor of A, 3 is factor of B. So that means with these two equations, A and B are not co-prime because 3 is common factor. So that means root 3 is rational assumption. Root 3 is equal to rational is wrong assumption. Means what? Assumption. Correct is what? Root 3 is equal to rational. Irrational. Sorry. Rational is wrong, irrational is correct. Opposite. So like this way, if you use common sense, with exact same process, any number, let it be 3, let it be root 5, root 7, root 11, root 7, any number you can write, same process you can do. If any number we can do prime number, if in place of prime number p letter is given, then also we can do. No, easily we can do. Let us try. Suppose we have to prove that p is irrational. Okay, in place of any 2, 3, 5, under root p is there. What will be there? Let p be a rational number. Then root p, no, let root p be a rational number, is root p. So here write root p is equal to p by q, a by b, co-prime, a, b, co-prime. Again same, here b, both sides square. No, so root p is equal to a by b, this. So then left side, right side is square. Root p square is equal to a square b square. That means here root p square means only p. P is equal to a square b square. So that means this p into b square. Here if you write p into b square is equal to a square. Here a square has two factors, b square and p. That means p is a factor of a square. P has to be a p prime factor. No, p is prime. P is a prime number. No, then only it is irrational. If P is a prime factor of A square, P has to be factor of A also. The same way, they write here in place of 3, P is factor of A square. So here P factor of A also, equation 1. Now if P is factor of A, that certainly P is equal to what? P into some another number, let it number be C. Okay, A equal to PC. If this is equation 2, put this A equal to PC value in equation A. Here in place of A, we will write PC. Here write with equation 3B square, left side. Here in place of 3B what? PB square is equal to, in place of A, PC. No, A is equal to PC. Here PC. Here PB square, left side PB. PB square is equal to P square C square. No, it will be here P square C square. This is only B square is equal to B. This P will come down. So here P square, no, here only B square is equal to, this B square is equal to P square C square. P square C square, this right, this P is down. Here P square by P, no, that means C square will cut, only PC square. So here B square is equal to PC square. So factor of B square is P and C square. Okay. So that means P prime, P is a prime factor of B square, P has to be a prime factor of B also. No. So B square is equal to PC square. Here P is factor of B square, prime factor, P prime number, prime factor of B square. That means P is factor of B also. Here we have proved. Earlier P is factor of A, here P is factor of B with this theorem equation B. Okay, then with these two equations A and B, P is factor of A, P is factor of B, A, B are not co-prime as P is common factor. That's why root P is equal to rational is wrong assumption. No, we have left P to rational. Wrong assumption. The correct one is root P is equal to irrational. Okay, like this, any number you can put. Okay, proof. So like this, we can do any number like this, we can prove. Okay. Now, let us prove another. Suppose now this theorem root 2 is irrational. No? By theorem 1.4, anything is written in theorem, that means we can code this as a proof to prove another thing. Okay, so like this with this theorem, no, root 2, root 3, any prime number under root P, no, is equal to irrational. This is proved irrational. Proved. Then we can use these numbers as a proof of irrational, certain irrational. So here, if we have to prove, suppose prove that 5 root 3 is equal to irrational. 5 root 3 is equal to irrational. Then what to do? Same way. If it is rational, it has to be no, A by B, co-prime. No, that time we have assumed. So let 5 minus root 3, this is minus root 3, is equal to A by B, where A and B co-prime. Then proceed this, side this, what we have to do? We have to bring this prime number under root, this means irrational one side. Let us do. Here is bring this side, it will be root 3, and if you bring this side, this will be minus A by B, like this, root 3. Here, see, we can A by B, this is O prime, and we can take, if LCM of this is B, so this is 5B minus A, like this, root 3. Here, certainly this is a irrational, no, proved irrational. Prime number under root. irrational. No, RHS. RHS is irrational. Here see, LHS is what? No number under root. No. No. That means these are what? Rational. LHS irrational. That means these are not equal. Equation is not equal. Okay? This equation is not equal. No. So that means this is no. Let assumption irrational is that means what? Let oblique assumption is not correct. Not correct. Therefore, correct is what? Correct is adverse, opposite. No. 5 minus root 3 is equal to rational. Okay, proof. Like this, any number, okay, any number if like this is given, we can do. No, we can do this is irrational. What we will do? We will select like this one side. Okay. Then any another number like this. Okay, one more number let us do. Proof itna irrational. Root 3 proof. Okay. Now, what is time? I think time is more. Okay, in this contest, let us do one more sum. Okay, then we will stop this video. Okay, then concept will be very much clear. If number is like this, suppose two number, irrational number, prove that this is also suppose like this. Like this. Suppose root 5 minus root 3 is irrational. Prove that. If we have to prove this only, then what we have to do? Then we have to do little bit different we have to do. What we will do? Root 5 minus root 3. Let these two numbers be A by B same way A and B are co-prime. Okay. Then again proceed this two irrational number with minus or plus. Then what we have to do? Both sides do square. Okay. So what will be there? Root 5 minus root 3 whole square equal to A by B whole square. Directly we can write, no? Both sides square. So A square by B square. Here let us do left side. A minus B whole square. That means what? A square B square minus 2AB. No? In place of this, we will write here root 5 square. A square plus B square means another number square minus 2 into first number into second number. A minus B whole square form. And this is what is equal to A square by B square. Now here root 5 square means 5, root 3 square means 3, and here minus what way? 5 into 3. Root 15. Okay. So this is root 5 root 15. Okay. 15 prime. Suppose this minus 3a square. If we put this number minus 3. Okay. So 2 into root 5 into root 3 and a square by b square. This 5 plus 3, 8 minus 2 what? Root 5 into root 3. No, 2 into root 5 into root 3 is equal to a square by b square. What is the idea here? How we will prove? This two number is certainly irrational. No, this is proof prime number under root. We will separate this number one side. Do separate. Okay. Only if you this full set you bring this side. So this minus sign will go as a plus. Bring this side. In place of this we will write here root 5 into root 3 2 minus. This is right side. So minus becomes plus. And this side already 8 and bring this side here. A square by b square like this. Okay. Here is equal to, you can take LCM, no, so that multiple form by 1, 8b square minus a square, like this, is equal to this, only root 5 into root 3, is equal to what? This, 8b square minus a square by b square. Here see two different number under root. Okay, this is IR irrational, whereas these all known number is under root. This is rational, and this is not equal. Irrational cannot be equal. That means same assumption. Okay, prove that. So let this. No, we have not assumed here. Let irrational, then only let root 5 by a by b. Here we have to write forgotten. Let root 5 minus root 3 be rational. Be rational. Then only it is like this, na, a by b, o prime. Opposite we have to let same. Then process is like this. So here, if one side prime number under root are there, it has to be irrational. Other part, no number under root. Okay. So then this is rational. And this equation is not correct. That means this assumption let root 5 minus root 3 be rational is not correct. Then correct is what? Right here. Root 5 minus root 3 is equal to rational. Let क्या है? Let equal to rational is wrong or not correct. Wrong. So correct is what? Opposite. Root 3 is equal to irrational. Correct. Is correct. Like this proof. Okay. So like this, any number like this type of we can prove. So here see exercise 1.3. Up to exercise 1.3, very easily you can prove in the irrationality of any number. Okay. I think you might have understood easily. Okay. Now I will stop this video. Okay. This paragraph irrationality of number, that means prove any prime number under root rational or multiple or plus minus irrational you can do easily. Okay, if you have understood it well, like my video, subscribe my channel, this career foundation, and good day. Okay, bye.